Hello, everyone. This is Brad Tallis with Next Gen Solutions. We'll get started here in just a minute or two. If anybody wants to help me out and say they can hear me okay, if you don't mind putting something in the chat or the Q&A, I'd appreciate it, making sure that technology is working correctly. Okay, awesome. Thank you, everybody that responded. Appreciate that. Okay, we'll wait just another minute or two, and then we'll get started. While we're waiting, I was asked to announce that there is a Power Mill Best Practices webinar tomorrow. If you're interested in that, you can sign up or RSVP on the Next Gen webpage. Um, there's also a state reimbursement training page that you can take a look at to get discounted or free training on any Autodesk design and make software. So I just wanted to do that quick announcement. Okay, let's go ahead and dive in here. I'm going to share my screen. I am running solo today. Usually I have somebody that kind of monitors the Q&A. So I'll try and check it every so often and answer your questions. So if it feels like I'm ignoring you, I'm not. I just can't see the screen. So give me a second here. Yeah, get the sharing going. Okay, 1 second. Screen two. Wow, come on. Okay, hopefully you guys can see my screen okay. Okay, gotta get organized here. Okay, once again, for those of you that have just joined, my name is Brad Tallis. I'm a fusion specialist with Next Gen Solutions. And today's topic, we're going to be talking about sheet metal. I'm going to be going through some tips and tricks, different methodologies, what some of the menus mean, and hopefully time permitting, even at the end, I'll show some like weird ways you can use sheet metal. Okay, so I'm in Fusion and I'm going to make sure, give me a second here. I want to make sure my chat window is up just in case anybody chats. Um, and you'll notice across the top, we have the solid tab, surfacing mesh, and then sheet metal. So I'm going to spend most of the time in this sheet metal tab. Now, one of the most important things with sheet metal is that it has to be a sheet metal component. And we're going to talk about that next. But basically, the first thing I wanted to talk about is the sheet metal rules. And you'll notice right here under modify, we have this sheet metal rules. And when I bring that up, you're going to see a list. Now, mine might look different than yours because Fusion just comes with about 6 default rules, sheet metal rules, that you can then use or modify or copy or modify. And so in fact, you'll notice I'm hovering over stainless steel right now and it says edit rule or new rule. Okay. And we're going to do this. And you'll notice I've created some new rules such as like 12 gauge steel and 10 gauge steel and aluminum and all this kind of stuff. So it comes with some default ones just to kind of give you an idea, and then you can create your own. And what I would recommend, especially if you have like a sheet metal shop or something like that, put in the materials that you use, and that way they'll be there for any project that you want to work on. So for example, I'm just going to hover over steel inch, and you'll notice I can say edit rule or new rule. Now, if I edit it, so I'm going to click on the little pencil icon, you can see it brings up the dialog with the name, the thickness, the K factor, etc. Okay, and I could actually change what this steel rule is, including we're going to talk about like bend conditions and corner conditions and all that kind of stuff. So you can modify the existing ones, or you can click on this little like page icon which says new rule. And this is what I do most of the time. I create a new rule. So for example, I could even create something like called cardboard, right? And what's the thickness? Let's just say it's 0.125 or something like that. Okay. So not only can you use sheet metal for sheet metal, you can use sheet metal for plastics, Lexan or polycarb or something like that, cardboard, whatever you can think of that can bend, you can actually use sheet metal to do that with. Now, the next thing in here is K factor, and you'll notice it says 0.44, and you can kind of think of that as 44%. And I'm not going to go into too much detail here, but K factors are different depending on the material. It might be different in steel than it is in aluminum. And what it basically is when you're bending you're taking the metal and you're bending it. Some of the metal is getting crunched or crushed, and some of the metal is getting stretched as it's making that bend. And somewhere in between, it's not getting compressed and it's not getting stretched. And that's basically the K factor axis. And typically it's about 44% of the way in. You can find K factor numbers out on the web for different materials. So if you did like K factor for 12 gauge steel, it'll tell you what those are. I'm just going to leave it default. Now, I wanted to point this out because this is one of the number one questions I get asked on sheet metal, and this will make more sense once we start creating parts. But the gap is really big when I create two bends where they come together. There's a pretty good sized gap, and that is right here, this miter, rip, or seam gap, and it says thickness. Well, what does that mean? Well, it's referencing whatever thickness is. So in this material, my miter, rip, or seam gap is going to be 0.125. Now, if we have time, I'll show you, we're going to do some math. I could say I want it to be, thickness divided by 2 or thickness divided by 4 or something like that. Or you could type in a number. I want it to be 0.025 or something like that. But that's the reason when we start folding parts, and you'll see this, why there's a pretty wide gap, because it's basically using whatever the material thickness is. Continuing on, these bend conditions, you'll notice, again, you'll see the word thickness quite a bit. So what is the default bend radius? It is going to be whatever the thickness of the material is, so 0.125. The relief shape by default is round, but you can see we could do straight and tear. And again, we're going to go through these, we'll actually see them on the screen as we're changing them. Relief width. So again, that's like if we were to do like a square or I'm sorry, a straight um, relief shape, it's going to look kind of like a rectangle or whatever, and that's going to be the width of the material, 0.125. And then you can see like the depth is half of what the thickness is. And this relief remnant is twice the thickness. And again, I'll explain this relief remnant once we start bending parts, but it basically, it's a formula that's saying if it gets below this number, don't create this remnant or whatever, because it might be too small to get punched out, for example. And then we get corner conditions, and you'll notice we have 2 bend intersection and 3 bend intersection. Most of the time, you'll probably be doing 2 bend intersections. And you can see in this example, the relief shape is round, but I have a bunch of different options. And, I typically use arc weld, for example, because, might be welding parts together. I want the seam close together. I don't want a big hole in the corner kind of a thing. But you can see round, square, tear, trim to bend, linear weld, and arc weld. And again, we're going to go through all of these once we have a sheet metal part up. And then again, you can see the relief size is whatever thickness is times 4. And this will make more sense once we get in there. And then pretty much the same thing for like 3 bend intersections. It just gives you a couple different options there. Okay, so the key thing here is we used an existing material. I said create a new rule from that material. So it basically used all of the information that Steel Inch used. So I didn't have to type a whole bunch of stuff in. It's basically like copying it, and then we're just editing a couple of those. So we just changed the thickness basically to 0.125. And I'm going to go ahead and save that. And now you can see I have cardboard in my sheet metal rules. And if I were to exit out of Fusion, this is automatically saved. It's attached to your login. So if you're on a different computer, um, you'll be able to log in on any computer and have all of your sheet metal rules. Somebody asked, is there going to be a recording? Yes, this is being recorded, and you will get an email with a link to the recording. Thanks for asking that. Okay, so the first thing you basically want to do is set up your sheet metal rules. Okay, then what you can do is I'm under the sheet metal tab. I'm going to say new component, and I'm going to move this onto the screen just in case video or something's covering it up. But you'll notice that the component type is sheet metal. And you can give it a name. So I'm just going to call it, box or whatever. But the important thing is right down here. You'll notice it says sheet metal rule. And if I click on that little down arrow, it's going to list all of the sheet metal rules that I have, including that brand new one I just created, that cardboard one. So you'll definitely want to pick which rule you want to use. Okay, so in this case, I might do I'll just do like, I'll do this 0.08 aluminum, let's just say, and I'll say, okay. And we now have a sheet metal component. The icon looks a little bit different. If I expand that open, you can see it's using the rule of aluminum 0.08 inches. Okay. Okay. Now what I can do is start to create my sheet metal part. So I click on create a sketch. I'm going to click on, like for example, the top plane, and let's just draw a quick rectangle. Now I can type in dimensions, so I can say I want this to be a 6x4 rectangle, and I'll say finish sketch. Now it doesn't look like anything sheet metal yet. The next command is flange, and this is actually a lot of commands in one. So you can use it to create a base flange, a contour flange, an edge flange, or a lofted flange, a bunch of different options here. And we'll go through each of these. So in this case, I'm actually going to use it to create what's called a base flange. So I click on the flange command, I get this menu, and it's asking for edges or profiles. So I'm going to go ahead and just click on that profile, and you can see that it gave it some thickness. Well, what thickness? 0.08, whatever the rule is, the sheet metal rule. You can see I also have different orientation, side 1 or side 2. So it's kind of like which extrusion direction do we want this to go? And I don't change this, but every once in a while there will be cases where I'll need to. And I'm just going to go ahead and say okay, and we now have a flat sheet metal part. I'm going to quickly create a couple flanges just to show you, how easy it is and what it does, and then I'm going to kind of dive deeper into the menu. So I'm going to say flange again, and it says edges or profiles. Well, we did a profile the first time, so let's do an edge this time. So I'm going to click on that edge, and as I start to drag this arrow up, you'll notice it automatically bends that material for me. Okay. What's the radius? It's using the material thickness, right? And then it's also asking for the height. So you'll notice we selected an edge. It's asking for a height. So let's just say 2 inches in this case. Okay. Now here is where some people get confused. What is this height datum? What is this bend position? So you'll notice this is like inner faces, outer faces, tangent to bend. And then we have this bend position, inside, outside, adjacent, and tangent. Okay, so I'm going to show you a little trick here in just a minute that kind of explains all this. Okay, so we're going to come back to the height and the bend position. We also have angle, and you'll notice we have this little dialog here that I can grab and rotate this. So you can kind of see how it's bending that sheet metal. So I could type in an angle there. Let me go ahead and set these to something like that. And so you can kind of see I could go either direction to specify that angle. I could also flip the direction. So even though I picked like that top edge up here, I can say flip, and it's going to basically select the bottom edge and flip the direction for me. And then we have this override rules, and I actually like this quite a bit. So if I check it, you'll notice it adds a lot more menu options in here. If it's unchecked, you don't see those. Okay, so I'm going to go ahead and say override rules. And the very first one is this bend override. And it's telling me what the bend radius is. Now I could come in here and say, I want that to be 0.25. And you'll notice that it's going to bend that at 0.25. So it's overriding the default rule and letting me specify my own bend radius. Okay, and sometimes you might want to do that, especially like, for example, let's just say this was cardboard or something like that, and we want a pretty small bend radius. I could come in here and say 0.008, and it looks more like something like that, for example. Okay, and then we have bend relief override, 2 bend corner override, and 3 bend corner override. So let me show you what these mean. So I'm going to go ahead and I've selected one edge. I'm going to go ahead and hold down my control key to select another edge. I want to control my selection. So I'm going to go ahead and select this edge here. And now you can see how it's bending both of those edges, and notice the round corner relief. That was the default corner relief. So let's take a look at this 2 bend corner override, and sure enough, it says the relief shape is round. I'm going to come in here and change it to square, and I'm just going to kind of go through these so you can see the differences. So there's like a tear, trim to bend, linear weld, and then arc weld. Kind of looks like that one there. And that's the one I typically use. Now, this is what I was talking about earlier with that seam, miter, rip, gap. Notice the width of it is about the same width as the material. So, because it was set to thickness. We're going to come in and we're going to change that. So this will be tighter together. So we don't have to weld as much material and all that kind of stuff. But that's the number one question that I get. What I don't recommend doing is leaving it like this and then try moving these faces to close the gap using like the move command and stuff. You can, but I don't recommend doing that. Okay. So that's what the different relief shapes are. And you saw these when I created the rule. I pointed these out so you can kind of see what they look like. Okay. So I'll just go ahead and set it back to round. Bend relief, let's take a look at that one. So I'm going to go ahead and say, okay, and I'm going to create another bend. So I'm going to say flange. And I'm going to do something really quick. We're going to come back to this in a minute, but I'm going to change, so I'm creating basically a bend right here in the middle of this vertical wall. And you can see this relief right here. Okay. So now I can come in and let's go ahead and edit that. Let's override the rules. And this is that bend relief override. And sure enough, you can see it says round. Let's just say straight, and you can see what that looks like straight, or we can say tear, and it's literally like you sliced right through there and you're bending it over. So there's hardly any relief whatsoever right there. Okay. So let's do the round. And once again, notice, for example, the relief width. This is the thickness of the material. I could make this smaller. Let's just say, 0.008, and you'll see it's almost like a tear, but there is a very slight relief there. Okay. So that's what these overrides allow you to do. Okay, so I'm going to cancel out of that. And we're going to come back to those. You're going to see me using those as we go through. So what I want to do now is explain some of these other options, like the height datum and the bend position, because this is where I think some people get confused. So I'm actually going to start out by creating just a regular component called box. And I'm going to create a shape. So let me just do a quick rectangle here. And I'm going to make it 4 by 3 by 2. So keep those numbers in mind. 4 by 3, and let's just do by 2. So if I were to measure this edge, we can see that that's 4 inches. This edge is 3 inches, and this edge is 2 inches. Okay. Then I'm going to come in and create a sheet metal component. Let's stick with this same aluminum since we're kind of comfortable with that number. I'll go ahead and say, let's just call this, I don't know, frame or something like that. I don't know. I'm just giving it a name. I'll create a sketch on this top face, and let's use that profile to create our flange. So I'm going to click on there, and you can see that it's creating a sheet metal component on top of our box. Okay. I'll say okay. Then I can come in here and I'm actually going to let's move this out. There we go. And I'll create a flange on that edge there and start to drag. Now watch what happens when I do this, okay? It creates the bend for me, but you'll notice, and it's kind of hard to see the box, but you can kind of see the corner here. It's creating that bend inside the box. And notice the bend position says inside. So if I click on this and say outside, you can now see that it's basically giving it a little bit more material and then coming down and bending, and it's bending outside the box. However, it's a sharp cornered box. It would intersect with, this material here. So let's change it from outside to adjacent. And now you'll notice what it's basically doing is starting the bend right on that edge, adjacent to that edge, and then it's creating its bend. Okay, so inside, outside, and then adjacent. Now we do have one more called tangent, and that doesn't really do anything in this example. It'll make more sense once we start changing angles and stuff. With a 90-degree angle, doesn't really matter. So we're going to come back to that one here in a minute. So I'm going to change this to outside. Okay. Now, the other thing is I know that this is a 4 by 3 by 2. So let's say the height is 2 inches. And you'll see that that comes all the way down to the bottom of the part. And you'll notice it says the height datum is inner faces. So what that's basically saying is it's going to be 2 inches from the inside down. If I were to change this to outer faces, notice how that kind of dropped back a little bit. Now it's measuring 2 inches from up here to here. So are you measuring from the outside of your box, or are you measuring from the inside of your box? And that's what this bend position, I'm sorry, this height datum is talking about, inner or outer. So I would obviously want it to be inner faces because the box is 2 inches. I want this, frame to be 2 inches. Hopefully that kind of visually explains what it is. Without this box, I think it's kind of hard to see what's going on. But if you can imagine you're wrapping, this sheet metal frame, around the box that you created. So we now have something that looks like this. We can see, the box is inside our sheet metal component. If we didn't round over the edges of the box, we'd probably want to use adjacent. That way the box can fit inside and there's room for it to fit inside, for example. Okay, hopefully that makes sense. Okay. Um, so the next thing I want to talk about are some of the flange options. So I just used a regular flange command to create these walls. Now I'm going to go ahead and select this edge. And here's a shortcut. If I pre-select the edge and right mouse click, you'll notice the flange command right here in my marking menu. So I don't have to come up here, click on flange, come over here, click on the edge. I can literally just select the edge, right mouse click and say flange. It's the exact same command. Okay, so I'm going to start to drag. We can see that it's creating my bend for me. We talked about changing the angle, changing the height, all that kind of stuff. Let's just make this, 1 inch long. Okay, now what is it 1 inch from? It's the inner faces. So you can see it's going from inside here to here. If I were to change this to outer faces, you'll see how it got a little bit shorter. There's inner, there's outer. So now it's measuring from the outside to there. So again, it's really up to you as the designer what you're wanting, the length of this tab to be. Is it measuring from the inside or the outside? Okay. What I wanted to point out is this right here. Not a lot of people know that this is actually an option because you don't see the pull down until you hover over it, which I find sort of odd, but it says full edge. So it's basically creating a flange along that whole edge that we picked. If I click this little down arrow, I can come in here and I have a couple different options, such as symmetric. When I do symmetric, you'll notice I get some more arrows. So I'm going to go ahead and start to drag. Now, what this is saying, and it's a little hard to see, but it's creating basically a symmetrical distance. And you can see it says 1.396 from the center. Okay, so let's make this an even number. Let's just say 1. So it's going 1 inch that direction and 1 inch that direction symmetrically. So if I were to say OK, click on that edge, sure enough, we can see that the length is 2 inches. Okay, and it does the bend relief for me automatically. Let's go ahead and edit that again. So that was symmetric. So it basically keeps the tab in the center of the edge that you've selected. You can't move this anywhere along this edge. You're stuck to being in the center, and then you're specifying basically half the width. So if I said 0.5, that tab is now 1 inch long. Okay. Great way to create a tab in the center of an edge. I use that one the majority of the time. The next one is two sides. So I'm going to say, actually, you know what? I'm going to go ahead and cancel that. Let's just do this, change it to two sides. You'll notice the arrows. And this time I can drag an arrow in one direction for a particular distance and an arrow in the other direction, a particular distance. And you'll notice I have two different distances in here. So I could say I want that to be 1 inch from the center, and I want this one to be 1.5 from the center. So it's no longer symmetric, right? But you're specifying from the center how far you want to go. Two sides. Let me really quickly show you what one of the options was remnant. So watch what happens when I keep dragging to the right. Notice how that disappeared and now it reappeared and then it disappears. So that's that bend relief remnant. If this bend relief gets too close to the edge, it's not going to leave that little bit of material because that might not punch very good or something like that, for example. So that was that one option when we were setting up the rule. is what is that remnant distance. So, okay. So that was full edge, symmetric, and then two sides. Let's do the last one here, which is two offsets. So I honestly use, unless it's a full edge, I use symmetric and two offsets the most. So two offsets is kind of cool because it allows you to specify a reference. So you're no longer stuck to the middle of the edge. So I'm going to go ahead and start to drag this, and you can see this number and how it's referencing the edge of um, this flange right here. So let's just say, -1. So it is 1 inch from this edge here over to the edge of our flange. I also have the ability to specify what the reference is. So right now it's on this edge right here. I'm going to go ahead and clear it, and let's select like that edge there, and I'll be able to, oops, let me do the other edge. Um, or do the face. Oh, sorry, I must have clicked something wrong. Let me go ahead and edit that guy again. You can pick a different reference, of course, in the demo. I'm trying to think of what would be a good reference here. So let's do reference. Yeah, I'm doing something wrong here. Sorry, guys, I'm rushing. Okay. Um, Let me do it on a different edge. Let's do that. Two offsets. I'll do both of these really quick. Specify the reference. Reference one. Ah, that is weird. It should let me pick a different reference and it's not. I'm not sure what I'm doing wrong here, guys. I apologize. Okay, anyways, you can do that. I honestly don't know what I'm doing wrong there. Um, but it allows you to specify the two offsets and specify a different reference. Not sure why it's not letting me. Um, and like I said, I use that one quite a bit, so I'm kind of surprised that it's not letting me do it. Okay, um, so those are the different options up here. And like I said, not a lot of people know that that exists because of it's missing that little down arrow. Okay, so we've talked about creating using the flange for creating the original sheet metal part, using the flange to create the walls, using the flange to then create like a tab or something like that. Here's another method you can use. Um, if I come in here and I create a sketch, I'm just going to go ahead, let's just pick maybe like that sketch there. And I'm going to draw I'm just going to project this point right there. And I'm just going to draw some weird shape like, like this, for example. A single line, well, I guess three lines connected, but no thickness or anything like that. I can come in here and say flange, and it says, what are the edges? So I'll go ahead and click on this. And if I start to drag, you'll notice it's doing this. It's basically creating what looks like another sheet metal part. But check this out. If I do the exact same thing, I say that edge and that edge, it joins them together. So it's a really good way of creating kind of complex angles and stuff like that, where you might want to dimension them or something. You could create a sketch and then join it to an existing sheet metal part. So kind of a cool way of doing that. You'll notice it says full edge. I could come in here and say symmetric and get something that looks like this, right? Think about how long it would take for you to model something like this without using the sheet metal module. Okay, I'll just go ahead and keep that. One of the tips I wanted to share that I do all the time is once I've done something, fairly complicated in sheet metal, I will come in and go under modify and say unfold. I'm going to go ahead and turn off the box. It's asking for a stationary entity. I'll click, for example, what I would say the most flat face. I'll just pick on this one here. And because unfold all bends was checked, it literally unfolds all the bends. And if it does, we know that this part is manufacturable. There's nothing wrong with this part. Okay. If it didn't unfold, we know something is wrong. Parts are, self-intersecting or whatever. And I'll show an example of that here in a little bit. So, okay. Let me check to make sure. Q&A. Let's see. I want to make sure. No questions. If you have any questions or comments or anything, please feel free to put them in the Q&A or in the chat. I'll try and answer them as we're going through. I know I'm covering a lot of topics here, so okay. Let's see. Oh yeah, so the next kind of flange that there is this lofted flange. So we've been doing this edge flange. So let me talk about the lofted flange really quick. So I'm going to create a new design. I'll say sheet metal. I'll use the same material, and I'm going to create two profiles just like you would with, doing a regular loft in Fusion. So let's just do a 6x4. I'll finish my sketch. I'm going to create what's called an offset plane. So I'm going to create another sketch a certain height, let's just say 5 inches up. I'll create a sketch on that plane, and let's just do like a circle, for example. And let's just make it 3.5. Okay. So I have these two profiles. Well, now when I come in here and I say flange, I'm going to say lofted flange, and it's asking for the profile. So I'll say that's one profile, and that's the other profile. And you can see it's doing all the hard work for us. And this doesn't have to be a circle. It could have been a slot shaped. It could have been a different size rectangle. It doesn't really matter. What it's trying to do is figure out how would it bend sheet metal to go from one shape to the other. You can see that it created the material on the inside. We could come in here and say, go to the outside. It's really up to you. So if you want this circle to be exactly, 3 inches, you would say side 2. Forming type, you'll notice we have break form or die form. So kind of like a rolled form. Let's go back to break form. I like this here. You have this facet control. You can see we can control how many facets by chord tolerance, by a facet angle. Like let's just say your machine can only fold, every 15 degrees or something like that. I could come in here and say 10 degrees, and it's going to add in more facet angles. I could specify a very specific facet distance. Let's just say 0.375, and it'll create as many facets as it needs to do that facet distance. Or we have facet number, which is what I typically use. So let's just do like 4 in this case. I'm going to go ahead and say okay, and we now have this really cool sheet metal component. And like I said, once I've done something kind of complicated, I'll come in here and I'll say unfold. I'll click on a flat face, and you'll notice it says, I can't. Well, why? Well, there's no opening, there's no seam or anything like that. So if I go under modify, you'll notice we have a command in here called rip. And we basically need to rip open an edge. So I'm going to go ahead. You can see it says face, edge, or vertex. Now, if I were to click on face, it's basically going to remove that face out of there. So I wouldn't do that. But I might come in here and say like this face right here. So I'm just going to click on that face. I'll say, okay, let's do an unfold. And this time it unfolded. And so this is manufacturable. So that's what the issue was that it was basically still a solid. There was no seam for it to know where to unfold it from. I'm going to go ahead and undo. So that's going to get filled back in. I'm going to undo so it no longer will unfold. And then the last option in here was face, edge, or vertex. Well, I can come in here and check this out. I'm going to hover over this edge, and you can see that it's kind of red. As I get near the middle, it's going to turn green. So it's basically snapped to the middle of that edge. So I'm going to click there, and then I'm just going to go ahead and click there. And we just ripped, and I can actually reposition that if I need to. But let's change the width to something pretty small and just say 0.02. So I just ripped right there on that flat face. So I'm not limited to having to select an existing face. I can actually position that rip wherever I want. Let's try the unfold. Sure enough, that worked. So, okay. Okay, another question I get quite often is how do you create a hem in Fusion? And unfortunately, currently, there is not a good way of doing this. There is no hem command or a safety edge. I think some people call them safety edges or something like that. So I do have a little tip, and I actually created, I think, a Fusion Friday on this. I'll just kind of go over it pretty quickly here. So I want to create a flange that kind of folds over on itself. So I'm going to select this edge. I'll say flange, and I'm going to start to drag. Okay. Now you'll notice by default, it's doing it at 90 degrees. So I'm going to go ahead and start to fold this over, but watch what happens. Let me set this back to inside. Yeah, interfaces. So this is kind of what it's default out of the box. So you'll notice as I start to rotate that my whole bend is kind of like moving, and this is getting shorter and longer and stuff like that. As I'm folding it over, you can see how it gets smaller and smaller. It's really kind of weird, right? Doesn't really make sense. So there's some settings here that will really help. If you're trying to create a hem, change the height datum to tangent to bend. Now watch what happens as I fold this over. You'll notice that that height is staying the same. Okay. Now it's still doing this weird bend thing, but this is no longer shrinking down. Okay. The next setting is the bend position. Change it to tangent. And now watch what happens. That bend position is staying put. And basically this bend is staying tangent to the bend right there. Now, if I fold it over to 180 degrees, we get that. I don't know why, and it's unfortunate, and you'll notice it's red, so it does not let us fold it over 180 degrees. I could come in here and say 179.999, and it works. So this, like I said, this is a workaround. I'm not overly pleased with it, but it is a workaround. Okay. Now, what about this? I want this to be kind of squished down. Well, here's where the override rules comes in. I can come in here to this bend override, and I could basically type a number in here. So I could say, like, for example, 0.008, and you can see how that gets much smaller. Or I could say 0.001, for example. Okay. Now, again, is this manufacturable depending on what tooling you're using, all that kind of stuff. So you might need to, set these numbers accordingly or whatever. So I'm going to go back. Let's just do like 0.05 in this case. But that is how I would create a hem. And if I said I want that to be 0.5 inches, it's now 0.5 inches, for example. So kind of a quick way of creating a hem. You just do both tangents and then you override the bend. So that's kind of a quick workaround for that. I will double check to make sure that this is still manufacturable. Sure enough, it still thinks that is, so we're good to go there. Okay. Um, again, okay, no questions. Hopefully this is all making sense. um, the next topic I wanted to talk about is you'll notice this bend command. And a lot of people think that's how you bend your sheet metal part. You use flange, right, to create your bends. What bend does is it allows you to start with a flat shape And using like sketches, you can say bend along this line. So let me show you an example of this. I'm going to go ahead, let's see, I'm going to open up a particular file here. Oh, here's what I want to do. Sorry. Let me close this guy out real quick. I'm going to create a new sheet metal component, and I'm going to insert in a DXF file. So I'm just going to go ahead and pick this DXF file, this flat pattern. When I say select, you'll see it'll come in. So this might have come in from a different CAD system, from AutoCAD or something like that. You'll notice there's some geometry, there's some overall shape, but then there's all these lines right here. And you can see that it's actually recognizing the DXF layers. And we have, for example, outer profile, interior profile, the bends, and then these bend extents. And that's basically showing like if this middle line is my bend, where is the tangent of this vertical face versus the horizontal face. So I don't really need the bend extents, but I do want the bend locations. So I'm going to go ahead and say, okay. And we just brought in this flat DXF. I can come in and say, let's create a flange. And I'll just select all of these regions here. And you'll notice I didn't have to select the holes or whatever. It's already punched those through. I'll go ahead and say, okay. I think give me a second here. I missed a profile. Let me add that in there. Now my sketch turned off. I'm going to go ahead and turn that back on. And this is kind of where the magic happens with the bend command. So I'm going to say bend. And it's asking for a stationary side. Well, I'm going to pick right here. I'm going to pick this face here. And then you'll notice when I get near this edge, okay, give me a second here. Why is it being weird? Wow, I am not having much luck today in my demo. I practiced this multiple times and it worked perfectly. I do not know. Oh, here we go. My bad. This is what happens when you rush. Add new selection. So I think that's what I need to do. Give me a second here. Wow. Create bend. Let me turn off that sketch. Stationary side. That's what I'm wondering is my stationary side on the wrong side? That's a good question. Because usually it turns blue. Let's try. Oh, I think, yeah, maybe that's what it was. Brian, if you're correct, I owe you a beer. Stationary side, let's try that. Yes, thank you, Brian. Saved my day. Um, okay, I apologize. This is what happens when you rush. It extruded up, and so you'll notice the sketch is sitting on the bottom, and so that's why when I was trying to click on the face, there wasn't one. So I'm just gonna flip it over. It'll still work fine. But what I could have done when I did my flange command is tell it to go the opposite side. Okay. So basically what I want to do now is I'm going to say bend. What's my stationary side? I'm just going to pick this flat area here, and then you'll notice it turns blue. So I'm going to go ahead and click right there, and it bends. Okay. And you can see this bend line, 90 degrees, all this kind of stuff. But what's important here is you'll notice where it's bending. It's bending from the start of that line. And I can come in here and say center, and now it's bending along the center of that line. Or I could say end, and now it's bending along, the end of that line. So I'm going to say center in this case. And then I'll do the exact same thing over here. We'll make that center. And then I'm just going to keep adding my selection. So now I'm going to pick on like this guy here, but I want that to bend the opposite direction. So I could just say flip bend, right? So I could click on that to flip the bend if I needed to. Okay. So I'm going to go ahead and select that. And I'm just kind of working my way in. and then I'll select this guy. And this is the one I definitely want to flip the direction. So I'm going to say, oops, I need to make sure I scroll down and flip that bend down. And now you can kind of see how we're starting to shape this part. I'll do another one here, bend down, and we're actually now complete. We're done with this sketch, and we just created this sheet metal component from a sketch. Okay. Um, so sometimes that's all you're given is a flat pattern or whatever, and you want to create it in 3D because you might want to make some changes or something like that. So you could bring in a flat pattern like this and then use the bend command to create the shape. Okay, not the smoothest demo, but we got through it. The other methods in here are convert to sheet metal. And this one's actually kind of cool because you might get a file from another CAD system, from a client or something like that, where it wasn't created in Fusion. So let's go ahead and I'm going to open up a file here, this upper bracket shelf. Okay, now it looks like sheet metal, right? But if I try to come in here and say, you'll notice my menu looks a little bit different. So I don't even see unfold or anything like that. And that's because it's not capturing any design history because it came in from a different CAD system. So I'm going to come in here and say convert to sheet metal. And you'll notice it says before you can use sheet metal, you must switch to the parametric modeling mode. This will capture the design history. So I'm going to say capture design history. And now we have a timeline. It's asking for a source. I'm just going to click on that flat face and you can see it detected the thickness of 0.105. Now, the the caveat with this is the object has to be equal thickness. So if these wings were 0.2 in thickness and this was 0.1 in thickness, this wouldn't work. It has to be all equal thickness. So you notice it detected 0.105. I can specify a default sheet metal rule. Like if I have one that uses tears instead of rounds, I could pick that one for that sheet metal rule. And then you'll see here that it says thickness will be changed to 0.105. So I'm just going to go ahead and say OK. And we now have a sheet metal component using the steel rule. And if I come in here and say unfold, and I click on that face, boom, we now have a flat pattern of an imported component that came from a different CAD system. In fact, this came from GrabCAD is where I downloaded this off of. And I'm able to, use this, cut it out of my laser, water jet, whatever. And I didn't have to remodel it. So there's a couple cool tips there. Okay. The next question I usually get is, what is the difference between creating a flat pattern and unfold? They both look like the same thing. So I'm going to say unfold, click on this guy. This is what it looks like. If I come in here and I say create a flat pattern, what's the stationary face? I say, okay, that's what it looks like, right? The difference is flat pattern. When I said create flat pattern, this basically puts you almost into like a manufacturing version of your sheet metal component. So let me show you what I mean by this. I'm gonna open up another design here real quick. Um, let's see, yeah, I'll do this, modify flat pattern. So here's a very simple example, okay? And it's kind of hard to see what's going on here, but this tab folds over and goes down through an opening. And I don't know if you can kind of see that. I'll slice through it, but you can kind of see there's an opening that this tab is going down into. Okay. If I were to inspect this really quick, let's just do a section analysis. You can see that there's room all the way around. Okay. So is this manufacturable? let's come in here and say modify, unfold. Sure enough, it is. But let's say this was made out of cardboard or something like that, and I want this tab to actually compress down into that hole, that slot, to basically get held in place. So I would, basically to show you what I'm doing here, I basically want this to be a little bit wider. So I'm going to go ahead and select both those faces. So you can kind of see how I've widened that out a little bit. I'll say, okay, hey, it looks happy. But if I come in here and say sheet metal rules unfold, you'll notice I get a warning. You can't do that. Okay. So how would I manufacture this? Well, this is where the flat pattern comes into play. So I undid it. We're back to normal. I can unfold this, no problem now. I'm going to create a flat pattern. What's my stationary face? That's my stationary face. And now I'm working in this version here. Okay. And I can literally come in and select these two faces and make them smaller. So in fact, I'm going to over exaggerate just to prove a point. So you can see that's, significantly smaller than that tab. I'll say finish flat pattern, and we're back to our design. But if I go into my flat pattern here, you'll see that it's smaller. Okay. And this is what's going to get manufactured. So flat pattern allows you to modify your design if necessary for manufacturability. And this is kind of a simple example. Hopefully that kind of makes sense. I could move things around. I could change things slightly, change widths or whatever. So this thing gets assembled together a little bit better. Okay. And you'll notice I could export this flat pattern as a DXF if I need to send it, to my laser or something like that. I could finish this flat pattern, and you can see we now have this flat pattern that's associated with our sheet metal component. So that's the main difference. Unfold does not let me do any of that. I can't change the shape or whatever. I mean, I could, but it doesn't let me do it for manufacturability. So hopefully that makes sense. Okay, we are running short on time. This is how it always works. Okay. Oh yeah, and I wanted to show this. So we're back to normal. This is another cool tip with sheet metal. Is you can use regular modeling commands. For example, I could create a fillet or a chamfer, on this sheet metal component. I can even do things such as, I'm going to go back to my solid tab and say, let's create a mirror. I want to mirror that. What's my mirror plane? I'll select that face there. We'll join them together. And notice this is all one shape now. Is it still a sheet metal part? Well, let's check by saying unfold. Sure enough, it is. This kind of blows me away. In fact, check this out. I'm gonna do this a couple times. So I'm gonna say mirror that to here. I'll do that again. Mirror plane to here. And just like that, we have this weird sheet metal clampy thing or whatever, where I literally drew one corner of it and I use the mirror command. If I come back into here and say unfold, is it still sheet metal? Yes, it is. So you can use regular modeling commands on sheet metal to do that. Pretty cool. Okay, let me bring up one more here, this SM mount. I also get questions on how do I create drawings of the sheet metal part shown isometrically, but also flat. And there's a little trick to this, okay? I'm going to start with my flat pattern. So I'm going to expand open this component. You'll notice it has a flat pattern. So I'm going to go ahead and activate that flat pattern. Now I'm going to come in and say new drawing from design. Let me move this over just in case. And notice the representation right here. It's kind of grayed out, but it says flat pattern. So that's what it's going to be creating a representation of. So let's just do like a C-size drawing. I'll say, okay, I'll do a manual right now. We have automatic, which is really cool. Automatically creates your sheets for you and all kind of stuff. Okay, so it's creating my title block, my border, all that kind of stuff. And then you'll notice that the flat pattern is associated to my cursor. Let's just go ahead and make that 1-to-1. I'm just going to go ahead and place that view. I'll say okay. Now I want to create a fold or a bend table. So I'm just going to click on table and you'll notice it automatically recognized there's a sheet metal component. So it's giving me a bend table. I'll just go ahead and place it down here and we can now see, the different IDs. So 7, 3, 2, 1, etc. And it's giving me the information in my bend table. But what if I want to show what this looks like folded together? So now I can come up here and say base view. So I'm going to click on base view and you can kind of see a 3D representation. Well, it's showing the front. Let's do like a northeast isometric. Let's make that 1-to-1. Let's make it shaded. I'll go ahead and place that view. And we now have a flat pattern with a table and a folded representation of that. So the trick here is do your flat pattern first, create the drawing of your flat pattern, and then bring in, the base view of the isometric. Okay. Any questions? I know we're like 1 minute over. I'll open it up for questions. Hopefully you guys learned something new about sheet metal. Feel free to throw it into the chat or the Q&A. I'll hang out for a few minutes. If you don't, I wanted to thank you for attending. Hopefully you learned something new. If you have any questions, please feel free to contact us through the Next Gen webpage, and we can hopefully get those answered for you. Okay, so Joe asked, I'm looking for K values for wood. That that is interesting. I don't know if that exists. Are you doing like layups where you're doing like individual thin layers and then bending those? Um, yeah, that would be that'd be interesting to figure out. I don't have an answer for that. I would probably man, how you could do some testing and see which fibers get crushed, which fibers get stretched, and then measure and kind of get an average percentage there. But like I said, most of the materials out there around 44%. It's usually in the 40s is typically the default K factor. Obviously, that's different for like cardboard or polycarb and stuff like that. But yeah, I don't have an answer for you for wood. Um, Yeah. Yeah, yeah, Joe's asking kind of the same question. Would it be lower or higher than 40%? I don't know. I don't want to say anything like, um, and if are you, I'm assuming you're bending, you're doing the thin sheets and stacking them into a form or whatever. Um, and if you're just trying to model the 3D model the part that you're creating, I would probably say in the 40% is what's typical. So that's a good question. I would almost if it were me, I mean, just being the nerd that I am, I'd do some testing and just see like what the results are. So okay. I don't see any other questions coming through. So I wanted to thank everybody and hope to see you on a future webinar and have a good rest of your day. Okay, actually, Rule said, oh, you know what? I apologize. If you guys are still on, one more thing I promised to show this was like how to close this gap. Okay, so I'm gonna come in here and we're using this aluminum rule. So let's come in here to sheet metal rules and I'm going to edit this, and notice it says miter rip seam gap is set to thickness. Let's do thickness divided by 4. I'm going to hit save, and notice what just happened to that corner. So just by changing instead of being thickness, I said I want a quarter the size of what the thickness is. So that's literally how simple it is to close that gap. I could also come in here and give it a number. So I could say I want that to be 0.001. And now it's a very tight gap, right? I could also come in here, edit this guy, and say, I want my corner conditions. I don't want them to be round. I like that arc weld. I'll hit save. And I might need to change, let's just change this to be thickness. Oops. Divided by 4. I need to change the rule. Let me go ahead and create a new flange. Let's see if we get a different result. Yeah, there we go. So you can kind of see how it's using a very tight seam there, for example. So I apologize. I promised I would show that earlier. Okay. With a small degree bend, one and 2 flanges on the front edges. Wouldn't let you override the miter. Okay, Raul, I'm going to ask if you don't mind reaching out to me. I'm going to post, I'm going to say Brad Tallis at nextgensolutions.com. I just threw my email into the chat. If you don't mind shooting me an email, we can maybe set up a quick Zoom call, take a look at what you're trying to do there. I'd like to get you over that speed bump and moving forward. And it might be best for you to like share your screen or an example of what you're trying to do. So please feel free to reach out to me. Um, and that actually pertains to everybody on the webinar. If you have any questions, please feel free to shoot me an email. So awesome. Okay. I hope everybody has a wonderful rest of your day and take it easy, and we'll see you on a future webinar. Thank you.